My name is Hans Rosenfeld. I'm a Illumos developer for the most part, living in Dresden, Germany, and been working pretty much exclusively on Illumos since 2012. I do a bit of NetBSD for fun, mostly on the digital VEX systems. And
That sounds
I'm sorry, what?
big sounds like a man.
Oh, that's true. Yeah, so in the past, during my career working on Illumos, I worked for Next Center, mostly on storage drivers. I worked for Giant, where I was a part of the team that imported bhyve into Illumos. The actual port was done by a company called Pluribus, I believe, to open Solaris. So it was quite old, and then we pulled in all the many improvements that FreeBSD did in the meantime and kept maintaining and improving it in Illumos for the SmartOS and Triton cloud environment that Giant built. Since 2020, I tried to get by as an engineering contractor, and yeah, that works sometimes and sometimes not quite as well. So today I'm going to talk about CPUID control for bhyve, which is one of the features that we're needing for live migrations, one of many features that we will need. And to structure my talk like this, I'll give a bit of technical background, explain how the CPUID emulation works in bhyve right now, then describe what is there already, the kernel bits that were necessary, the user space bits to use the kernel bits, and from there we're getting to what I'm actually want to do next is what I sent as a proposal to the FreeBSD Foundation, is make CPUID control actually usable, but we'll get to that. The technical background, I don't know how many of you actually know what CPUID is or isn't. So let's start there. Back in the old days, it wasn't always easy for an operating system or a hypervisor even to know what it's running on. Usually you want to know what CPU vendor is it, what family, what model, what stepping, what features does it have, what instruction set does it support, what's the topology, what do the caches look like? And also, most recently, what are the errata that I have to expect to run into? What are the vulnerabilities in CPUs, which is apparently a thing recently, and of course, the mitigations for these vulnerabilities. And up to about 1993, talking about x86, the other architectures had this much earlier, you would use some handcrafted assembly code to test for presence of certain instructions and obscure side effects, and then make a deduction what CPU and model and family and vendor you're actually on. And you would have to have embedded hard-coded knowledge about what features that these CPUs have and what errata they have and how to handle that stuff. And in 1993, Intel introduced the CPU adaptation to the x86 architecture with the original Intel Pentium. And you have one instruction and you can ask the CPU for all kinds of stuff. And this data is structured into what they call leaves. And some leaves have optional indices where you get even more information. And the structuring has allowed this to be extended and be used by multiple vendors. All of the information does diverge a bit from vendor to vendor. The CPUID leaf you're interested in is passed in EAX register, ECX if you need an index, and it uses EAX, EBX, EDX, and ECX to return the information. That means on 64-bit systems, the upper 32 bits of the registers kept clear. And this is what it looks like in assembly to get the most basic CPUID leaf, which is 0, and uses no indices. And this is basically the result that I'm getting on my laptop for that. It tells me how far can I take the CPUID stuff. So the maximum leaf is D, and then it tells me that I'm running on a genuine Intel system, which apparently is a good thing. Other vendors report other stuff. And this brings us to the next step. We need to emulate CPUID in bhyve. Pretty much most stuff that the VM might ask for can be passed through from the host CPU because there's really nothing secret about it. We want to mask some features. We definitely mask out VMX and SVM. We mask out speed step thermal monitoring, all kinds of stuff, which the virtual CPU has no business dealing with the virtual machine doesn't need to care. And other things we have to modify in the CPUID information as we get it from the hardware, which is stuff about the SMP topology, as the virtual topology of the virtual machine has nothing to do with the real one. Same for cache topology, probably, and also things like hypervisor identification and hypervisor features. I know that KVM and Hyper-V are making a lot of use of that. bhyve, I believe, only supports the basic CPUID leaf for hypervisors, which is, funnily enough, in a reserved area that no CPU will ever use. And that leads us to the missing features that we have issues with when we want to do live migration. The biggest problem is, what if the receiving VM host uses a different CPU, even a slightly different CPU? It may be lacking a feature that the VM has come to expect. It may be suffering from a vulnerability that the sending host didn't have. So the VM doesn't expect to suddenly run on a system where it has to do something about a vulnerability. And even worse, that's where I get the most complaints about, is you make a change in the CPU model brand string topology, you may lose your proprietary software license because it thinks you've moved it to a different system. And this is actually a problem even if you're migrating your VM offline, shutting it down and booting it up on another host. Another thing that's been asked for is to modify the hypervisor signature so that we can identify as KVM or Hyper-V or whatever we want, because also there are some softwares making assumptions if it's not running on a physical hardware, it's checking the hypervisor signature, and if it's not KVM, it just refuses to work. Other stuff is feature masking architectural downgrade. That's probably going the same direction as the NUMA stuff in bhyve. It's mostly for software development, OS development in particular. Okay, so there is a bit of the stuff that we already have. The kernel bits have been implemented by Oxide for their Propolis hypervisor. Propolis uses the bhyve kernel parts on Illumas, but they have their completely own user space code written in Rust. And they implemented live migration a couple years ago already. And for that, they added CPUID control. So basically, you have an I/O control where you can configure the CPUID data for a vCPU, and it replaces the entire CPUID emulation for that vCPU. You can actually do different stuff for different vCPUs, but that's, apart from a few small things where I'm getting to in a minute, is probably just screwing stuff up. So you usually need to configure every vCPU of a VM if you want to change the CPUID information. It does not do any sanity or safety checks of the data that you send there. If you want to screw it up, you can. It's very easy. And then, of course, when you do that, you must make sure that you match the VM configuration, especially when it comes to the number of CPUs, SMP topology, and things like that. This was relatively easy to port to FreeBSD and is out for review. Has been out for review since July, I believe. And now we're getting to the user space plot because the kernel part alone isn't really all that useful. I did that in July and put it out for review. And what it does is it adds a wrapper to the I/O control interface to the VMM API. It adds options to bhyve for the bhyve configuration file to set CPUID information, global CPUID information, and per vCPU information, and then constructs a set of CPUID information for each vCPU out of the stuff that you give it. And of course, I needed a way to check that the kernel actually got what I configured, so I added a command to bhyve control. But it's not exactly user-friendly. It's really just access to the raw data that the CPU gets, and this is what the configuration actually looks like. If you think that is terrible, this is not even 10% of it. It's like a whole lot more. What you can see here is a couple of global CPUID values that are used for all vCPUs. And since the VM I did this on has just two vCPUs, I have an override for vCPU1, where, for instance, I'm setting the APIC ID to 1 so that the system knows what it's doing. Yes. Yeah.
So, leave is not specified for a specific vCPU. Does it see the default one? And if so, can you hide one just on one vCPU?
I'm getting to that in a minute. Because that's exactly that. It's not really usable. Well, you can use it, but it's terrible. The way I did this for the test VM is that I ran the VM without any changes, ran the CPUID utility, piped it through an awk script that created the options, and then started filling with bits after consoling the documentation. What would be much more useful is that if I don't have to specify the APIC ID, for instance, if the system would do that, I give it global options and the stuff that need to be at certain values, it will just do that automatically. One way I think we can do that is that if we pass CPUID information into bhyve, it will pass them again through the emulation code where it does these changes. That's currently not done. That's not something that Oxide implemented in the kernel part. Probably they didn't need that. They have something similar for CPUID stuff that needs to change when certain MSRs are written, but that's something else. Or, as you asked for, you can specify data where you just want to override a single register that is returned, or even just turn on or turn off bits. So what I'm doing here is I'm overriding in CPUID leave 1 the bit that says the CPU has a processor serial number. Or here I'm just turning off, I wonder what it is. Anyway, some feature that isn't particularly necessary. And over there, the next line, I'm setting the actual processor serial number that I turned on. The processor serial number was a feature of the Pentium 3 architecture, so that's really old. No CPU has supported it since then. But with that, you can have it on a VM on a modern system. I don't think it's particularly useful, but it can be done. Going from there, if you want to override a hypervisor identification, it would be nice if you could do it just like that, or something like that. And even if you want to say, I just want to specify a particular real CPU, if we add a CPUID database to bhyve, we can specify the brand string and it'll fill in the rest, or you specify an x86 architecture level, or you downgrade it to an Intel 486 if you like.
If you specify a concrete CPU like i7 there, would that also control the number of cores you have?
It could be. It's not really there yet. This isn't implemented. But I guess the number of cores that you're configuring could be independent of that. So you could have a 32-core i7 from the first generation or something. Or you could have a 32-core, well, probably not a 486, but an original Pentium P5 if you want, for whichever reason. Probably OS testing. I mean, NetBSD is still supporting the systems very well. Yes, Wave?
Is this specific to x86?
Yes, this is all specific to x86. I mean, other architectures, I guess ARM64 has similar mechanism and probably not as much problems with that because it's a much younger architecture. But this is really all x86 only. So this is this on the slide before that is what I have proposed to the FreeBSD Foundation, that we make this useful. Going from there, it's the second part that Michael showed. The problem that we have when it comes to FreeBSD and Illumos and diverging code bases. So Illumos imported a really old version of bhyve back in 2017 and then pulled in all the changes from FreeBSD and then has been working on that. Some of the stuff that Illumos did has made it back to FreeBSD, but I believe since 2020, not much has happened there. Illumos is continually pulling from FreeBSD, but most recently they've started to leave out kernel bits because the systems have diverged too much, and a lot of the kernel changes they weren't interested in, like GPU pass-through stuff. And of course, the code was refactored and reorganized everywhere. So that is really a pain in the neck. this is an awful lot of work to figure that stuff out. We really want to basically go through the commit list of both operating systems and walk them one by one. And each one that we port in one direction or the other, well, probably just port to FreeBSD needs to be tested individually, as we don't want to break things. I did go through the list of the Illumos commits yesterday and looked at some stuff that I think is interesting if you want live migration in FreeBSD's bhyve. The bhyve test suite was not necessary for that, but it's nice to have. That started out at Giant, and Oxide has been continually improving that. Oxide has added dirty page tracking, which I think we really want. They have made changes so that the kernel device state for the devices that the kernel side emulates directly, like the APIC and other low-level stuff that the architecture needs. That is exposed completely to user space, so you can save it and send it on over. Same with vCPU states. CPUID control we were talking about, and they also added VM was resume, which is not exactly the same as suspend resume, but definitely needed for full live migration. And there is more. There's about 5 years worth of changes, although the stuff that's relevant for live migration, I think, made it into Illumos in 2023 already. Some of that, like the CPUID controls from 22, so it's a bit older than that. So I think at this point I can conclude my presentation. If you have any more questions or any suggestions, then please speak up.
Dave, you might have answers on this. What does the diversity of ARM64 look like if it were to be a CPU type topology and profile? Is it far simpler than Intel?
I don't know, but there's generally saw them.
But I don't know. I'll look. Appreciate it. Want to appreciate your questions? Yes.
So this was very interesting. Thank you very much. Which bit of it did you enjoy the most, and why? And is there therapy available for this? Yeah.
Is there what?
Therapy, yeah. The joke. Yeah. Which bit did you like the most and why?
Well, first of all, I don't think there's a therapy for that. And I just enjoy fiddling with bits. And so, yeah, just porting this stuff is usually a bit of nasty work because you have to work out all the difference in the code. But actually getting in there and changing stuff at such a low level and most likely break everything that's running in a VM in the process and then try to figure out how to make it actually work is something that I think is a great fun.
I'm curious about, I don't know anything about the Illumos community. I'd be very interested if you could just maybe sketch, you say there's a lot of stuff happening around its like who's active? Like, is it mostly Oxide or are there a lot of companies and individuals involved? I was just...
Certainly not a lot of companies. So in the past, there were a handful, and that I believe that shrunk a bit. So what once was Giant is now owned by a company called Edgecast. They're still doing Triton and the Triton Cloud, still developing SmarterOS. Oxide is a pretty big part by now. And I think all the storage vendors have pulled out. So they were bought up. I was contracting for them for a while, and then they at some point said they're just supporting existing customers and not doing any new developments. There's a couple companies in Europe that use it, and I'm right now at this moment contracting for one that wants Word.io SCSI on Illumos for SCSI pass-through. And the community in itself is small, and anyone can contribute. You don't have to be a member as you do in most BSD communities. And there's a core team which I'm on, which basically gets to decide what goes in and what not. But this is following a formalized process, so there's really no reason, okay, we don't like you or we don't like the change. If it passes code review, then and you can provide testing, then it usually goes in. So it's not much room for interpersonal conflicts there, I hope.
Thanks.
So for those who have watched the calls, there is Andrew H. and Mark G. There was a point that I think Andrew's attended more calls than I have, which is impressive. They are both with Promenic in Illinois, an ISP on-premises that catered to a lot of ex-IBM Domino and Friends applications, all on OmniOS, all on super early bhyve before it was even ready on Illumos. And they came to the calls with great questions, great energy, great everything. And they're just an invaluable part of that community. And so thank you, Promenic. If you're looking for hosting, I'll gladly push them. Diversity is very, very important. And just I touched on very briefly Meet BSD. There was VBSDCon with VeriSign, a completely dual stack company with Linux and FreeBSD to keep .com running. Diversity is really, really important.
Well, Michael, this might be a question for you, but how do you two see the reconciliation of the changes in Illumos and FreeBSD? I guess the calls are the start for it, but is there any suggestion how to start? I suppose FreeBSD is upstream in this case.
Well, my take on it is just something that needs to be done, that should be done. It should be beneficial to both projects. I mean, wouldn't it be amazing if we could do live migration between a Lumos host and a FreeBSD host, for instance? And I don't think there's a reason why that shouldn't work.
You heard it here.
But I'm not sure that's actually a useful feature, but it would be awesome if it worked. That being said, it's going to be an awful lot of work, and it's going to be tedious and not very interesting. You really just have to go, okay, what was done on one side on the project, what was done on the other, and how did it diverge? And if I go back like 5 years and take the changes from Illumos and starting there, I have to adapt them to current bhyve and not to the state of bhyve and FreeBSD 5 years ago. So I have to adapt all of that to the things that have changed in FreeBSD right now and have to test them. And this is what makes it tedious and a lot of work, especially the testing requirements. Well, how to get it started? Well, just do it. And ideally someone to fund it. That would be awesome.
And how many subject matter experts do we have on a mix of Illumos and FreeBSD? I can count one so far. Thank you, because Hans, like, wow, we are blessed to have you doing this, because generally people come from whatever camp, from their first days in college on a Unix system and just stayed with one or two OSs. But the fact that you cross the aisle, as they say, is invaluable, and I appreciate that. A similar discussion is taking place with OpenZFS. Illumos is still on their original ZFS, and they cherry pick from OpenZFS, and people want those latest and greatest features. They want, you name it, XML output, all sorts of things. So I think Illumos is very much a friend of the BSDs. You can look at that as not Linux, but hey, that's, look at it from whatever perspective you please. But I think that diversity is critical. Any other questions for Hans, be it on bhyve Illumos zones, anything else? And there's a point in many of the calls when Hans and Andrew and Mark start discussing crossbow networking. And they have warm towels and cookies and a mint on your pillow. They have so many nice things that came out of Sun that such attention to detail went into and are performant and consistent, and just put ADM on anything on the end of any function you can think about maintaining in the OS. So I think we all have a lot to learn from Illumos, yet you're still in GCC. Is that true? Yes. Okay. Well, someday some Clang LVM, and I know there are projects for ARM64 out there and RISC-V, but they're definitely not our enemies. That's for sure. And it's been a delight to work with everyone like Hans. So thank you. And if there are any other questions, great. But let's move on. Thank you.
Thank you very much.